Welcome to homework.
So for question 1, it was asking us what is the path difference corresponding to the force dark band, okay? And the equation for the path difference is delta L equal to 2m plus 1 times lambda over 2, okay? So since it's talking about the force band, okay? So the force dark band from the central bright fringe is associated with m equal to 3. So therefore, if we plug in m equal to 3, we'll get the path difference for the force dark band. Okay, lambda here is the wavelength, and the delta L is just the path difference. And we'll get delta L is equal to 2 times 3 plus 1 times lambda, which is given as 500 nanometers. Okay, so times 500. That's 500 nanometers over 2, and this will give us 1750 nanometers for the path difference. And for question B, it was asking us, what is the distance on the screen between the central bright band and the first bright band on either side of the central band? Okay, so well, first we know the sine theta, which is the angular position theta of the first bright band on either side of the central band, can be given as sine theta, which is equal to lambda over d. That's for the first bright band. Okay, in this case m is equal to 1, and that's why it's lambda over d. Okay, and d is just the slit separation, is the distance between the slits. So distance on screen, or let's say the screen separation, which is delta y, is equal to d times tangent theta. So delta y is equal to d times tangent theta. And in this question, since it's double slit question, so the distance between the slit is much smaller than the distance from the slit to the screen, which means that angle theta is really small. So if the theta is really small, it means that if theta small, let's say really small, that means tangent theta can be approximately equal to theta, and same for the sine theta as well. Okay, and this will give us tangent theta is nearly equal to sine theta. Okay, so delta y can actually become equal to d times sine theta, and I will show you here, which is, so delta y is actually can be equal to d times sine theta. And the angular position of dark bands can be given as sine theta equal to, let's say, d sine theta. So it can be given as d sine theta equal to m plus 1/2 lambda. This is for the dark bands. Okay, so sine theta is equal to m plus 1/2 times lambda over d. Okay, so therefore delta y is equal to d sine theta, which is equal to d times m plus 1/2 times lambda over d. And this will give us the changing screen separation, or the changing y, delta y is can be given as d lambda over d, and which is equal to delta y times 1 over m plus 1/2. And remember, for this case, it's associated with the fourth dark band, so m is equal to 3. So if we plug in m equal to 3, we'll get delta y times 1 over 3 plus 1/2, which is equal to delta y times 1 over 7 over 2. Okay, so d lambda over d is equal to 2 over 7 times delta y. If we plug in the delta y value, which is 1.68 centimeters, we'll get, so 2 over 7 times 1.68 centimeters. Oop. We get it. The distance on the screen between the central bright band and the first bright band is 0.48 centimeters, which is 4.8 millimeter. Okay, and this is the question. This is the answer for the question. Thank you.